Okay, hi everyone. My name is Mark, and I thought I would show you, or rather, I was asked about where to put the horizon line in a drawing. So I'm using a little program here called GeoGebra, which is used to show, well, this sort of thing. It's a problem of geometry. This is a question of geometry. So here's a hypothetical situation. I've got a 40. Let's suppose. It's a very complex question that requires, it depends on a bunch of things. It depends on your field of vision, and it also depends on your relation, meaning the viewpoint, viewer's relation to the ground, where that horizon is, as well as the angle, your viewing angle, whether you're looking up or looking down. So if I were to let's say have, let's say I had a fixed segment like this. Whoops. Yeah, this thing is always kind of glitchy. Okay. So let's say I have a viewing angle like this. This is my drawing plane. So if you had a piece of paper, you can treat the piece of paper or their drawing frame as a little window through which you stare through. And I'm just going to create a couple of rays. So let's make a ray from here to here and from here to here. Okay. So if your viewing plane, right, this is the thing, this is your viewing plane, this is your vantage point. So the thing is, your vantage point is not the piece of paper. Your vantage point actually sits kind of behind a piece of paper. If you were to look at this, my drawing tablet, right, you have a point of view. That's where this camera is, right? I can take this camera and I can point it around and whatnot. But as it is, this piece of paper here, right, your viewing angle spreads out and matches up with those four corners. So if I were to, let's say, unhook this camera or like move it around and have it staring at the page, right, like the thing is that this is what's happening, right? Your vantage point is moving relative to the picture frame, relative to the window, the viewport, as it's also known as in computer graphics terms. So again, this is what's happening. This is the camera that is sitting behind the picture plane, and it's moving around like this. Now, normally you would be perpendicular to the picture plane, and what happens is something like this, right? So the idea is that if you move around, your picture plane is always perpendicular, right? This way, whatever you're seeing beyond the picture plane is properly projected onto this picture plane and doesn't distort. And in fact, if you had a hypothetical situation of, say, a panoramic view, if you had a panoramic view, what panoramic cameras often do is they take, iPhone panoramic camera apps will often take multiple pictures like so, and then they'll stitch them together, right? So what they do is they take multiple pictures. Oops, that's segment mode. I need to be in ray mode. Come on. There we are. Work with me here. Right? So this is what happens is you take multiple pictures and you stitch them all together. And I need to be back in movement mode. There we are. Right? So this is what's happening, right? You're taking several pictures, you're sticking them together in order to prevent the massive amounts of distortion. And the fact that and ironically, when you see like these three pictures all stitched together on your iPhone and or BlackBerry, whatever, your phone has a flat screen. And so what happens is it's taking this little, this big wide open view, and it's kind of shoving it down so that it fits inside a small picture plane. That's why you see the distortion, is because you're taking this relatively spherical, this curvilinear perspective, and you're zooming out so far to the point where you start seeing some squished edges. So if you were to look at this camera here, right? If I look all the way down there, okay, like just within this small room, you can even tell that back wall is close up, and it gets further away, right? That corner is further than this part of the wall. Whatever you're looking at perpendicularly is going to be close, and whatever you're looking at tangentially is going to be further away. So you can even also see, like, if I as I tilt this camera up, there's a curvature, right? If I just turn it left and right, I'm just swiveling it left and right, I'm just yawing it, you can even see how the edge of that ceiling is flat here and it's curving. I'm not doing any funky tricks with the camera. In fact, I'm probably not holding it quite as straight as I can, but there is a definite, curvature. If you just look up in the corner of your own room, you will see it. Do it. Like, just don't take my word for it. See for yourself. And the same thing goes to the floor. So this is it's a very complex situation, is what I'm trying to say. But I mean, you can understand it just by opening your eyes and looking around. Swivel that neck of yours. So if we had, in this case, I've locked the picture plane down to exactly 45-degree angle. The field of vision is locked down to 45 degrees. And also, oh, hang on, let me undo the deletion of that. Can I undo? Here we are. Let me just nuke some of these little picture planes, these extra ones. So if you get really close to the picture plane, then you wind up seeing a wider field of vision. Your field of vision widens, and when you get further away from it, you get a narrower field of view. And the size of an object in the picture plane is dependent on how much of the viewing angle is taken up. So if I were to, say, create a little circle here, okay, now that circle only takes up like a third or maybe a quarter of the entire viewing angle. But if I pull back, you'll see that now the circle takes up a much larger amount of the picture plane. So it gets bigger. So this is what happens when you zoom in. When you zoom in, you're pushing that viewpoint back, right? And you're zooming in, you're getting your field of vision to crunch down, and things wind up flattening a lot more. Whereas when we go over here, okay, now this sphere here, right? We're seeing the sphere from this side, right? Whereas if we move the sphere up here, let me just bring that over. Actually, here, let me create a new sphere. I'll make a sphere using a fixed radius. So let's say, I don't know, 0.01. Okay. So in this case, the sphere with the fixed radius, right, this is going to be very small in the picture frame. This is going to take up a large amount of the picture frame, right? And also, if I were to pull back, right, this thing now takes up a huge amount of the picture frame. It takes up only a little, right? And then also, if we're here, we're seeing the underside of the sphere. Here, we're seeing the top of the sphere, right? All very important things to understand and keep track of. So this thing here, all right, I've got this huge kind of ground plane, this big area that you're seeing underneath. That's our ground plane, okay? And somewhere off, way off to the right, I don't know, somewhere over, come on now. Come. I hate it when it does this. I have to zoom out until it behaves, and it is totally misbehaving. Okay, here we are. All right, so great. I gave away the fact that we're actually sitting on this massive planet, and I zoomed in, and the program doesn't handle being zoomed in very well. So yeah, the thing is that point, it goes off to the horizon. That's a tangent on this giant sphere of a planet, and so if you're looking up into the sky, you don't see the horizon. Now you see the horizon just begins to appear at the bottom of the picture frame. Now the horizon should be dead center of the picture frame, and now we should be seeing the top of the picture frame, right? And if we change our elevation, right, we can also see how the picture frame is changing its angle, right? So picture frame is changing its angle, and where that horizon is sitting within the picture frame is changing. You have to understand this geometric relationship. And just like I showed earlier with the sphere, right? If I pull back, right, we're now on a really, really high. We're on a satellite, pretty much, and you can see how, right? We like, look, now you can really see that curvature, right? If you look straight down, you'll be seeing the tops of buildings, whereas if you look this way, you'll be seeing the sides of buildings, because the buildings must cling. They cling to the surface of the sphere, and they also follow perpendicularly the surface of that sphere. So, well, actually, here I can just make another ray. Now let's just make a ray from here to here, and I should be able to move this guy around there. Right. So the thing is, here you'd be seeing the side of the building. Here you'd be seeing the top of the building. Right. So very, very important to understand this relationship of perspective. So in a situation like, say, like this, right? Then you're seeing that the horizon line here is only taking up, it's just below the midline, right? So something like that would you get a horizon kind of like this, where the horizon is kind of just below the midline, whereas something like maybe like this, right? Something like this, where you're looking down, right about here in the midline, you'd be seeing planets. Well, sorry, you'd be seeing the buildings at kind of a 45-degree angle like that, right? So you'd be seeing something more like this. Now, if you want to practice, and you have to practice this and make it into something that's second nature, because when you practice and make something second nature, it becomes part of your subconscious. Your subconscious is something you can leverage very easily. The thing, like when you're walking, you don't think about where to put your feet, right? You just do it. When you were a kid, when you were a baby, or a toddler, when you're a toddler, you learn to walk. You practice these things. There's not much else to do, really. You practice walking. You make it second nature. Now we can walk, we can run, we can crawl, we can somersault and dive. And it becomes second nature, and it's something that you don't even have to think about. Now most people can generally walk and chew gum and like play around on their cell phone at the same time. You can only multitask when things are a part of your subconscious. So the thing about drawing and being a really good artist is you essentially have to make yourself into something akin to a parkour artist, which means someone who can multitask. You got to be able to do this thing and that thing and that thing and that thing. You got to deal with like the subjective, and you got to deal with the objective, and you have to deal with plot and composition, and how the hell do you make all this stuff go together? You learn each one of these things, and you practice them, and you embed them into your subconscious, and you make them second nature. So I'm going to show you some exercises to help you embed this stuff into your subconscious, and it's up to you to become comfortable with it. The only time that you really master something is when you can do it without even thinking about it. So in this case, you start with a sphere, okay, and then you start placing coins, right? Just think of them as little coins, and you're planting these coins on the surface of the sphere. Okay, and of course you could also, if you get really good at it, then you could. Right, this is what you have practice. You have to get really good at this. And of course, your hand and your eye aren't going to do what you want them to do because you're a noob. It's all right. It's okay. Everyone's a noob. I was a noob once. I wasn't born able to do this. I would have been a freak. But this is the thing: is I'm able to draw and change the orientation of this coin, and then at the same time I can begin extruding these things into cylinders, right? So you're seeing a definite change in the angle of the object, right? This is what, and also the you'll see that this really feels like it comes outwards, right? So it's a three-dimensional thing. It's a three-dimensional optical illusion that you have to be able to pull off, right? So you cover that thing with coils, and you do it again and again and again. If you're not satisfied with your results, if you don't feel like it was easy for you, do it again. And if you still don't feel like it was easy for you, and you're still having trouble with it, do it again. And if you're having a really tough time of it today, do it tomorrow. And if you're having a tough time of it tomorrow, do it the day after. Just keep doing this stuff. And if you're about to go to sleep and you kind of, you're not quite tired, bring your sketchbook to bed and do them until you fall asleep. Get really, really good at this. I cannot stress enough like how useful this is, how much easier it makes it. And the thing is, things are only easy, like, if you think of it like, say, lifting weights. If you are some puny, weak, scrawny doughboy guy like me, lifting weights is really hard. On the other hand, the more you work out and the stronger you get, the easier it gets to lift those same weights. Okay, so that's what I mean, is that in terms of drawing skill, those are the muscles that I've worked on and have turned to something that is second nature. And I'm good at it not because I was born with it, because I worked at it and I busted my ass on it, and I did I've done all the things that I'm telling you to do right now. In fact, I'm speaking to you as if I was speaking to myself from several years ago when I wasn't good at drawing. It's basically a message to my past self. And this same exercise, I call it a spherical array. You can use it for practicing things. You want to draw eyes, you want to draw mouths, you want to draw hands and fingers, any kind of anatomical body part. Make a sphere, cover it in that object. It'll look really creepy. It'll be horrifying. It will keep you up at night, but that's fine because you need to be not drowsy. You need to be awake for this stuff because it's hard. All right? Do these exercises. You'll thank me later. Trust me. It's really I'm proof of I'm basically living proof that this stuff works, okay? So, hope this was helpful, and I guess I will talk to you all soon. Thanks again. Bye.